Welcome to lecture 35, Useful Array Methods. So in this lecture, I just want to go over 3 useful methods that arrays have built into them. So any array that you make by default, whether it's an integer array, a double array, string array, anything it is, they have these built-in functions that you can use. So by going over them, I just want you to know that they are there, and if you want to use them, you can. So because we did searching in the last lecture, I want to do the first method on a type of search. It's called a binary search, and it's pretty complex, but it's built into the default array data type. So when we did searching in the last lecture, we did what is called a sequential search. Basically, what that means is that we checked every single element in the array for whatever we're searching on. We did a sequential search, we checked every single one. So if there was 5 elements, we checked every single element to see if it matched. Whereas a binary search is a different type of search that can actually be more efficient in certain situations. It's more efficient because it cuts down the search space by a certain ratio, depending on certain conditions. If these conditions are true, then a binary search can be a candidate of a type of search that you can use. It all comes down to what type of search you want to do. So let's start off by actually declaring a new array and using it to mess around. So let's say int my array. Now, the one thing to note about a binary search, and I'm going to explain more about it, how it works here in a second, but the information, if you're doing a binary search, must be in order. So if I'm doing numbers, it has to be in order. So I'm going to say, let's say 10, 15, 20, 25, 30, 35, 40. Okay. I need an equal sign. Okay, so we have our array. So let's say we were searching for some information in here. We'll get the information for the user of whatever they want to search. So I'll say to the console, enter number to check if it exists. So we're just checking to see if the number exists in this array. We're doing a basic search. This is a binary search though. So I'll get that number. I'll say int number equals int.parse console.readline. So whatever they type in is now stored into number. So basically, I want to check this number to see if it's inside the array. So like I said, we're going to perform a binary search. So how does a binary search work? Let's add one more number to make it 45, just so it can make it a little bit easier to see. How does a binary search work? And this is how it does it. This is how a binary search is more efficient in this case. If the numbers are in order, a binary search can be more efficient because this is what happens. Let's say I'm searching for, 40, right? I'm looking for the number 40. With the old method, or well, not the old method, the sequential search method that we looked at in the last lecture, we would have to check every single one. So we would have to say, okay, is it 10? Is it 15, 20, 30, 40, 35? Okay, now we found it at 40. So we had to check all of them through it. But what a binary search does, because the data is in order, it basically cuts it in half. So it starts off by saying, okay, let's start at the midpoint. So 30 is the midpoint, we start there. It says, the number that you're searching for, is it greater than or less than 30? In our case, 40, we're looking for 40, is greater than 30. So the binary search is going to go to the right-hand side of the midpoint. And then it goes to the midpoint of the right-hand side. So that's going to be 40. Then it will say, okay, is that what you're looking for? If it is, then that's your answer. If it's not, then we'll go either left or right of that, depending on whether it's greater than or less than that. So as you can see, that only took 2 searches. If we're using a binary search and we're looking for 40, it only takes 2 searches. It starts at 30, it goes to the right, and it goes to the midpoint of the right-hand side, which is 40. Boom, it found its answer right there. Now, if we were searching for 40 using a sequential search, we would have to check all of them. So that would take 1, 2, 3, 4, 5, 6 checks. It would take 6 checks compared to 2 checks of a binary search. And that's why a binary search is a lot more efficient if the information is in order. It can only do this if it's in order because when they're in order and it finds a midpoint, it knows the numbers to the right of it are greater than it, and it knows the numbers to the left of it are less than it. Without that information, you can't perform a binary search. So it has to be in order if you're going to do a binary search. So you could imagine that if we had a million or maybe 50,000 numbers we were searching against, if we had to search every single one and the number was in the middle, that could be 10,000 searches. Whereas if we did a binary search, that could end up being maybe 10 or 6 or 7 searches. It can dramatically increase it. It grows basically exponentially, the search space, how fast it goes when the numbers increase of the integer or whatever you're doing. As the array gets bigger, the binary search basically becomes more and more efficient over the sequential search. Now, obviously, if this is getting into like kind of data structures a little bit, if your information inside of your array is not sorted, then you're going to run into a problem. Is it efficient to then sort it first and then do a binary search, or should I just go ahead and just do a regular sequential search? And how are you going to get your data sorted? Is it being entered sorted? If it's getting entered sorted, then that's a perfect candidate for a binary search. But there's all different things that factor into this, and eventually I'll probably make a course on data structures alone because it's a big topic that you could talk about. But this is just a little taste of data structures talking about this binary search. It's not that important to know right now just because you're beginning your programming career, but it's definitely good to know. So anyway, how do we perform the binary search? So we're not going to actually write our own binary search, which you can. We're just going to use Microsoft's binary search that's built into all the arrays by default. And basically, there's a binary search method attached to this array class. So you type in array.binary search. And the way the binary search works is whatever you're searching for, if it is not found, it returns a -1. So if it does not find it inside the collection or inside the array, it returns a -1. If it is inside the array and it does find it, it will return that position inside the array. For example, if I was searching for 15 using a binary search and it found this 15, the function or the method gives to me its position. So it would say 1 to me. And that's what we're going to look at right now. So we have what they entered in. Now I'm going to actually run the binary search. So I'm going to say int, we'll say, I don't know, answer. This is the answer of the binary search equals array. The reason why I'm saying int answer is because array dot, like I said, binary search returns either a -1 or a number that represents its position. So that's why we're going to set it equal to an integer so we can see the result of it. So int answer equals array.binary search. Now it's saying, okay, I need an array, so I'm going to give it an array, comma, and then what I'm searching for number. So this is the syntax. Array.binary search is going to search it. I'm going to give it the array that I'm searching in, and I'm going to give it the number I want to search for, which is whatever was typed in. I just passed that in right there. Now, remember, it has to be in order. It will not work if it's not. And now it returns the answer. So we'll just say if answer is less than 0, that means that it did not exist. It's not inside the array, because remember, if it's -1, that means it does not exist. So I'm going to say console.writeLine, the number does not exist. Else, I'm just going to give it its position. I'm going to console.writeLine and say the number's position in the array is, and I'm going to plug in the answer, because the answer is the position if it's not -1. So let's go ahead and see how that works. Enter number to check if it exists. I'm going to type in, let's say, 41st. So the number position in the array is 5. So let's check 0, 1, 2, 3, 4, 5. So it was correct. It did find it. Let's try another one. Let's try 10. So the position is 0, so it found it again. And now let's try one that does not exist, 55. The number does not exist. So it's doing the same thing that we did with that sequential search, where we checked every single one, and then we returned if it exists or if it did not exist. It's doing the same thing like that, however, it's slightly different, and it's also performing a binary search. Like I said, sequential search, this is what I really want you to remember out of this lecture, is that a sequential search searches every single element inside the array. So if there's 10 elements, it's going to check every single one. Whereas a binary search can skip. It uses this, it cuts it in half, and it keeps on cutting it in half and half and half, and it can go dramatically faster. There's actually a runtime. There's basically runtime speeds of how fast these algorithms go, and a binary search is faster. However, it's faster. However, the data that you're searching on needs to be sorted, and that could potentially be a hard task to have. I mean, if the data is completely unsorted, you can't use a binary search. You need to figure out if you can, should you sort it, and things like that. Okay, so this is the binary search. Let me go ahead and add that to the comment. Now I'm going to comment this all out again. Now let's move on to the next function that I want to talk about that's built into the array, and that's the array sort method. So let's say we had another integer array. So int my array equals 10, 5, 7, 2, 55. Okay, it's out of order, random numbers. And I want to sort this information. So there's a built-in sort method that we can use, and that's what I want to go over. So what we can do is we can call array.sort on our array. So we can say array.sort, passing in my array. And now my array will be sorted. So if we wanted to now print out the array, how would we do that? We would use a for loop. For int I equals 0 as long as I is less than my array dot length I plus plus. That's standard. It's iterating over the array, and I'm going to print out my array console.array line, my array sub I, and hopefully our data will be in order. So as you can see, it was originally 10, 5, 7, 2, 55, and then it got sorted to 2, 5, 7, 10, 15. 55. So it is in order. So array.sort, passing in, you type array.sort, and then in the parentheses, you pass in the array. I'm saying pass in a lot, and that's because this is a function, and when we talk about functions and methods, you'll understand why I'm saying that. But basically, you just do array.sort, and inside the parentheses, you type in my array, and that will do the sorting on that array. So this is sorting an array. And then the last thing I want to talk about in this lecture, the last useful function that you can use, is the reverse function, which basically just reverses the order of it. So let's say we had, again, int my array equals 10, 5, 7, 2, 55. Now, I did show you another way that you can reverse it before in one of the other lectures, but this is another way you can reverse it by doing array.reverse. So I'm going to do array.reverse, typing in for my array, and then once I reverse it, now I can just print it. So I'm just going to go ahead and take that loop, which prints it out, and I'm just going to uncomment that, and let's see what happens. So it was originally 10 to 55, and now it's 55 to 10. So it flipped the order and it reversed it. So that's actually it for this lecture. I just wanted to go over the binary search, which is a little confusing. And if you don't understand that, don't worry too much, because like I said, a binary search is a complicated topic, and you will learn about it in the future. Definitely not in this video series, but in the future of your programming career, definitely. Then we have the sorting method that sorts whatever type of array it is. It sorts it in order. And then the last one is array.reverse, which just reverses the order of your array. So these are just 3 useful methods that you can use when you're dealing with arrays. So let me just go ahead and reverse. Comment that out. So like I said, that's it for this lecture. These 3 functions are very powerful. So anytime you need to do these tasks, it's good to use these because they're already built by Microsoft and they're very efficient.